Hello everyone. Today we'll discuss the important aspect of antithyroid drugs, that is called synthesis of thyroid hormones called T3 and T4. How these T3 and T4 are synthesized and released into the bloodstream. The first step is from the hypothalamus there is a release of TRH, thyroid releasing hormone. It acts on the anterior pituitary cells, that is specific type of receptor present on the anterior pituitary cells called GQ type of G protein coupled receptors. When there is a stimulation of GQ, there is a increased levels of inositol triphosphate diacyl glycerol, that is second messengers. Because of this, there is increased intracellular calcium. Okay, because of this, there is a release of thyroid stimulating hormone from the anterior pituitary cells. This thyroid stimulating hormone, it will go and act on the specific type of receptors are present on the thyroid follicular cells. They are called GS type of G protein coupled receptors. Their TRH, GQ type of GPCR, TSH, GS type of G protein coupled receptors. When they will go and bind to the GS, okay, that is specific type of G protein coupled receptor, there is the increased level of cyclic AMP. Okay, when this GS stimulation increased cyclic AMP levels, it leads into transcription, translation, and finally synthesis of proteins. Mainly there are two type of proteins are synthesized. One is iodide channels inside the thyroid follicular cells. These iodide channels are helpful for the uptake of iodide present in the blood stream into the thyroid follicular cells. Otherwise, whatever the iodide present in the bloodstream, it will be taken up by the thyroid follicular cells through these iodide channels, which are synthesized by this stimulation of GS type of G protein coupled receptors inside the thyroid follicular cells. Understood? After this, iodide is synthesized or taken up by the thyroid follicular cells. This is the first step in the synthesis of thyroid hormones, that is called iodide uptake. So inside the thyroid follicular cells, this iodide is fused with tyrosine amino acid molecule. If one iodide fused with tyrosine, there is a formation of MIT, monoiodotyrosine. If there is a two iodide molecules are fused with tyrosine, there is a formation of DIT. So total one MIT and two diiodotyrosine molecules are synthesized inside the thyroid follicular cells. After this, if monoiodotyrosine combines with diiodotyrosine, there is a formation of T3. If DIT combines with another molecule of diiodotyrosine, there is a formation of T4. So synthesis of MIT, DIT, and there is a formation of T3, T4, which is catalyzed by the specific enzyme called thyroid peroxidase or thyroperoxidase. By this way, T3 and T4 are released into the periphery from the thyroid follicular cells, that is bloodstream. Okay, among these T3 and T4, T3 is more active, T4 is less active. So most of the T4 is converted to T3 in the bloodstream for its action with the help of enzyme called 5-deiodinase. This is nothing but deiodinization process. So by the enzyme 5-deiodinase, T3, most of the T4 is converted to T3 and it produces its action. That is T3 and T4 synthesis inside the thyroid follicular cells, released into the bloodstream, and most of the T4 again converted to T3, and this T3 produces its action. Okay, this is the overall synthesis and release of T3 T4 into the bloodstream for its specific action. Thank you.